Continue. Good morning, everyone. Today we're going to continue what we left off last week at Basic 35A, continued practice. Okay, and let's see. Do you have any questions? Let's try. Let's see. Did you guys try something over the weekend? All right. Let's get started, and I'm going to show you how to do this work and what are the do's and don'ts. And so hopefully this will warm you up. Okay, so we have we have an expression here, which is like this. It looks pretty messy, right? It looks pretty messy. But guess what? This is a question you may encounter in your calculus class. Okay, we're doing the algebraic part. Okay, we are doing the algebraic part. And we're not doing the other parts, right? The taking limits and stuff like that. Okay, so how do we simplify this? How do we rationalize? Okay. All right. First of all, we know this is just a statement. Okay. This statement could be, it could be also called expression. So we're working on this expression. And what we do is that we're going to rationalize the numerator. We're going to rationalize the numerator. To rationalize the numerator, one of the things we will do, of course, we're going to multiply the conjugate. We're going to multiply the conjugate of the numerator. And what is the conjugate of the numerator? The conjugate of the numerator, which was root x minus square root of x plus h, and its conjugate will be the square root of x plus the square root of x plus h. So it's simply, so conjugates are of these two forms. So the conjugate a plus b is the conjugate of a minus b. Okay, so that form, right? So our capital A, capital B, capital A, capital B. So A minus B and A plus B are conjugates to each other. So now we have A minus B, then its conjugate is A plus B. Now, the quantity we multiply has to be 1 because anything times 1 stay the same. So we need to maintain this equal sign to be the same as the given expression, okay? So with that, right, so the first one, the numerator we multiply here is to make that A minus B times A plus B situation and divided by the same quantity, which makes 1. This entire quantity is 1. So we're multiplying this by 1. Okay, so anything times 1 stay the same. So that was just the explanation of how to, choose the quantity to multiply so that we can reach the goal of rationalizing the numerator. Now, with that said and done, we will have the numerator. We could apply the properties of conjugates, right? Because we know that if we got the conjugates, these conjugates multiply each other, and that's going to equals to a squared minus b squared. That's what we want. Okay, so we have that situation, A minus B times A plus B. Okay, so these are the situation we have. So in the numerator, okay, the numerator would be, we multiply these two. Let me rewrite the step. That's on the numerator. Denominator. Okay, we have a denominator here, and that's going to multiply the other denominator because we're doing the product of fractions, right? Numerator times numerator, denominator times denominator. All right. This step is not entirely necessary for you to show, but I show it because I want to show you what's going on. Okay, as you get better, you can skip this step and go to the next one. Okay. Now, is that done? Okay, we're going to apply the a squared minus b squared, right? So a minus b times a plus b. So what we'll have the square root of x, that's the capital A squared minus capital B, which is the square root of x plus 1, x plus h. Okay, so x plus h, and that's been squared. Okay. The denominator, on the denominator, what do? Don't do anything. Nothing. Just copy and paste. Just copy and paste. Don't try to distribute. Okay. Don't distribute. Don't take this one, multiply that. Don't take this one, multiply that. Don't distribute. Okay. You will understand why. You're going to see why here, and you're going to see more when you get in calculus class. So just stay the factor form. Keep it in the factor form. Now, the next part. Okay. The next part we get to use what we mentioned last time. Okay. What did we mention last time? Well, we mentioned a lot of things last time, right? One of the things we mentioned last time is a difference between this square and the other one, a square inside versus a square outside. Okay, I even put these on the quiz. Do you guys, can you tell me what the answer to this guy and why? It's entirely determined by the domain, right? And when we write the square root of x, and that implies x has to be greater than or equal to 0. So as a result, this equals to x. And the other one, the domain of square root of x squared is all real numbers. Therefore, and for this guy, it's going to equals to the absolute value of x. Okay, so we get to use this piece. We get to use this piece over here. So over here, we're going to get x, and over here, we're going to have x plus h. All right? Okay. Now we're almost there. We're almost there. After this this operation, we're gonna open up the parentheses. So now you distribute the negative sign into the parentheses. So that's a minus x minus h. Okay. A common mistake would be, you forget to change this sign to negative. And x minus x, of course, makes 0, right? So one more step. You can totally condense some of these steps here, but I just do it so that everybody can catch up. Okay, everybody can follow. Now, we have a negative h on the top. The denominator are in factor form. Okay, keep the denominator in factored form, please. And by this time, we can reduce the h because we have a factor h on the top and we have a factor h in the bottom. Gone. And you keep it that way. You keep it this way, okay? You keep it this way in this class. You also keep it this way when you are in calculus class. This is just a preview of your calculus class question. Okay, this is really just a preview of your calculus class question. And you're done. We are done here. For this class, or for your calculus class, you have a couple more steps follows. Okay. All right, so this is the rationalization of the numerator. Are you ready to give it a try? So how about you guys try this one? Okay, try exactly the same one we just did. Okay, get your paper pencil. Okay, I want to get you to take the steps and go through the steps. Okay, 175%. All right, so write down the steps and then you get another piece of paper. Okay, you try to do it all by yourself. Okay, so now how about you do it? Okay, you start from here. Get a piece of paper, a fresh piece of paper, and do it on yourself. Do it by yourself. Okay, don't look at the screen. Don't look at the screen. Yeah, just look at the paper. Don't look at the screen. Oh, you can always peek. You can always peek, right? So let's do that to warm up. Let's do that to warm up. And go ahead to do that. And I'm just going to get a cup of tea and I'll be right back. You will find that it gets easier and easier, right? It gets easier and easier. Okay, regarding the factor form in the denominator, the general principle is that don't multiply, don't expand, just keep it that way. Okay, just keep it that way, especially in this case. You see the advantage today, which allow us to cross out simplify the h. You're going to see more advantage when you are in calculus class. Okay, you'll feel it's much easier to handle this situation then multiply them out. Okay, so the general rule of thumb, just keep them factored. Keep them factored if you can. Okay, keep things factored. That's why this also explains the importance of factoring, right? The importance of factoring. Got it? Okay. So you can do it, right? You can do it. It's just a matter of practice. And you realize it's so much easier to do if you do it, right? When I was teaching calculus class, and I was of course we did this question when I was teaching Math 190. A lot of students, they just get freaked out. They get freaked out by questions like this, right? Isn't that pretty, distressing? It's very distressing. It's very distressing. But on the other hand, you just need a little more practice. You just need a little more practice, then you'll be ready. You'll be ready for that class. You need to be algebraically very strong in order to survive that class and the following classes. Okay, so now let's look at another question. Okay, this time I'm gonna attack number 4 with you. Number 4. Number 4 may look a little bit weird for you, and especially you're asked to rationalize the numerator. I said, why? Why do I have to do that? This looks simple enough. Well, in calculus class, you will have to do that. And why? You will keep that question mark in your mind. Okay, your calculus class professor will explain to you why. So we're just handling the algebraic part. Okay, we're just handling the algebraic part. So we see this as a fraction divided by 1. That's how we see this. So that's what rationalize the numerator will come in, right? And of course, we are just going to have this x squared. Oops, x squared plus x minus x. Okay, now to rationalize it, of course, you're going to view this as a fraction over 1, and you're going to multiply, okay, the conjugate of the numerator, okay, over the conjugate of the numerator, right? You're going to multiply by 1. So that number 1 is going to be chosen according to what we have in the existing numerator. The existing numerator is that guy. So a minus b. So you just change this, change this side. So it becomes a plus b, right? If you have an a plus b, you make it a minus b. But anyway, you just create that conjugate situation. We created that conjugate situation. Okay, and of course, we're going to make the same denominator. So as a result, this is just a 1. This is just number 1. Okay, anything times 1 stay the same. Do you follow me? Anything times 1 stay the same, but you carefully choose the number 1. Okay, we carefully choose number 1. Okay, now, and the rest is similar. The rest is similar. And this time, of course, our denominator is much simpler, right? And the numerator, you just multiply, use a squared minus b squared, right? A is identified. So this is a squared minus b squared. Right? And then you apply, so the top is going to be x squared plus x minus x squared. Excuse me. Denominator, like that. Equals to, now, this time, x squared minus x squared, that's going to make 0. Okay. In your actual class of calculus class, you might have to do one more step. Okay, so finally, we have rationalized the numerator. Okay. Depending on the situation you're in your calculus class. Okay, depending on the situation you're in. If x is positive, you may have to do one more step. Okay, which is dividing every term by x. Okay, so I'm going to, this is the optional step. Okay, possibly in calculus class. Okay, so from here, okay, suppose x is positive. Okay, so from here, you may possibly do the following. You may need to. Okay, so x is a positive, and in particular, x, you might be told x is approaching positive infinity. Okay, that's one scenario. Okay. So what you might have to do next, okay, it depends on the question you have in calculus class, okay? If you are in this scenario, the other thing you're going to do is that you're going to divide both top and bottom. Okay, so this guy, you're going to divide by x. And the entire denominator is also going to be dividing by x. Okay, so let me make this just a little bit larger in fonts. Okay, so these are the possible algebraic manipulation you may have to do. Now, x divided by x is 1, right? Denominator, when you take this x divided into these two parts in the fractions, you're going to have this guy over here divided by x. And over here, you have another x divided by x. You guys follow me? Okay, and next, this is 1, right? This is just 1. So the emphasis is focused on this part, this piece. And what we want to is we want to bring this x inside the square root. Okay, we want to bring this x inside the square root. If we bring the x inside the square root, what are we getting? Because x is positive, right? Because x is positive. So the square root of x squared, right? Remember this expression, right? This expression. Okay. The absolute value, this expression, okay, there's a, let me show, let me give you a little more details, okay? Now, the square root of x squared is equals to what? Is equals to absolute value of x. Okay, and this guy is equals to what? It is equals to two cases, right? The same as x if x is positive. Opposite if x is negative. Okay, we don't consider equal to 0 because in our case, x cannot be 0, okay? In our cases, x cannot be 0. So now, why is this important? In this case, in this branch, I assume that x is positive. So we'll be using this branch. Okay, we'll be using this branch because the absolute value of the number of a positive number is going to be the same number. So that's how this positive x can smoothly go inside. But what if it's negative? If it's negative, you're going to have an extra negative sign here outside. Okay. All right. Now, with that said and done, you turn the entire expression. You're gonna put the whole thing. You're gonna put the whole thing x squared. It becomes something like that. You see, in calculus class, a lot of the things you not only have to be fluent with algebra, you have to be fluent in algebra in every way. Okay, so now what do we have? One last step. You take this x squared, divide it into each. So you're going to end up with what? 1 plus 1 over x. That's what you end up with. And then you can carry it out your next step, taking limit. Oh man, right? So the handling of algebra, I just give you a glimpse, a preview of some of the algebraic techniques you need. It's not entirely, you have to handle this in different ways and with all these basic knowledge, okay, correct information, okay? So let me show you another scenario. What if x is negative, x approaching negative infinity? What will happen? Right? What will happen? Because there will be a situation that x is approaching negative infinity. Okay, so suppose the scenario is reversed. X is negative and it's approaching negative infinity. Okay, if that's the case, this step will look very different. Will look a little bit different. Let me say it's I say it's different. It's going to be different. Why is it going to be different? We're still going to be using this piece of information, which we are pretty familiar with, right? And the goal is still to move this x inside the root. And what do you do? What do you do? Well, knowing x is negative, x itself is negative. Okay, x itself is negative. So you're going to be using the other branch. Okay, you're going to be using the other branch. But how do you use the other branch and still keep it equal? Right? How do you use the other branch? You will need a negative x. Okay, you will need a negative x. Hold on, let me make it larger. 300%, right? So you're going to multiply a negative sign. And then why do you do that? Well, watch, okay? The absolute value of a negative number is its opposite. So by having this negative sign here, okay, of course, I need to balance it, right? I put a negative sign here. I also need to put a negative sign here. So that's multiplied by 1. Anything times 1 stay the same, okay? Do you follow me? Okay. So I inserted this negative sign on the numerator, on the denominator. I'm also inserting this negative sign on the numerator. And this piece, it becomes what? The next step, that piece will become the absolute value of x. Because the absolute value of x of a negative number is its opposite. So this guy is the negative x. Okay, so this guy is this negative x because x is a negative. You follow me? Now this can be rewritten as this guy. Do you follow me? Now you can finally bring this back in. Okay, now this is square root of x squared. Right, these minor details. Okay, and then you can bring them in together. You can bring them in together, but you have a negative sign as an extra. You follow me? You have this negative sign. You didn't have that negative sign in the other scenario. So finally, you're going to have something like this. Okay, the x squared go inside. Okay, you have a negative sign. And inside is going to be like, it's going to be 1 plus 1 over x. If x approaching negative infinity, x approaching negative infinity. Okay, the scenario could be different, but on this part, you have that situation. Okay, as a matter of fact, I have a calculus textbook with me. The exact question is slightly different. That question is slightly different. I want you guys to try this. Okay, you guys try this. Okay. It's a little tricky. It's a tricky one. I remember when I was teaching that calculus class, going through these steps, I had to spend time there. I mean, I have no problem to spend time there, but oh gosh, a lot of students really had a hard time. Okay. So let me grab that question, the exact question for you. See if I can, I want you to try what do we have now. Okay. This piece and the next piece. 2.3. So 2.3. Okay, try to manipulate those. In the positive number situation, it's much easier to handle, but in the negative number situation, it's a little tricky. Okay, tricky. You can do it. Okay, it's all from that basic knowledge. Okay. The exact question that you have to do this in calculus 1, this question is in section 2.6, number 28. Number 28. Okay, so I'm just going to type that question. Okay. That question goes like this. Okay, so now I want to train you guys to do this. Well, if you don't have to do this when you're taking calculus class, you're lucky, right? But I doubt it. The scenario you have to work with is removing the calculus part, right? You have a 4x squared. Okay, this is a version number 8. It's a version number 8. 8th edition. Okay, this is the 8th edition of calculus text. Plus 3x. Okay, plus 2x. And it's x approaching negative infinity situation. So it's x less than 0. And x is approaching negative infinity. Okay, so let's do this. Okay, so in this scenario, x is negative. Okay, shall we do this together? Let's do this together. First, you have to rationalize it. Okay, multiply the conjugate of this guy. It's plus here, now it's a minus. Does everybody follow? Okay. And next, we got the denominator, 1 times that, so there's no change. Denominator stay the same. Numerator, you just have x squared, a squared minus b squared, right? So you have this over here, so that's a squared minus b squared. Does everybody follow me? Right? A squared minus b squared. And then, and of course, this piece, you get 4x squared plus 3x, right? And over here, you're gonna have 4x squared, right? So you have 4x squared minus 4x squared, that's gone. So you're gonna end up with something like this. There. Similar to what we did before, right? Similar to what we did before. Okay, so a calculus situation. Okay, partial. I say partial because we're only handling the algebraic part. Okay, we're only handling the algebraic part. So are you there? Are you with me? What do we do next? You get to this point, you cannot finish that question. Following, the new things you learn in calculus class, taking limit, right? So what you have to do is you're gonna have to divide the top and bottom by x. Okay, so this guy, you divide by x. This piece, you're gonna divide by x. And that piece, you're gonna divide by x. So, okay. So that is just anything times 1 stay the same. You basically divide by x on the top and divide by x in the bottom. Okay, so what you did here is really what you did, is really this guy, 1 over x, 1 over x. Okay, that's what you really did to get to next step. Okay, all right. All right. Now, the top is easy, right? This is just 3. And this piece is easy, that's just 2. How about this piece? That piece is where you get to use this guy. Okay, remember, in this case, x is negative. Okay, because we have a scenario that x is approaching negative infinity, x is negative. Okay, so what you want to do is you want to absorb, you want to take this x inside the root, the square root. But how do you get there? You can't just take it inside and turn it into x squared. You have to be mindful of the sign of x. Okay, so I'm going to put a note here to see how this is worked out. Okay, you say since x is negative. Okay, since x is negative. Okay, since x is negative, the absolute value of x is equals to negative x. Right? We're following this branch, right? We're following this branch, this branch. That is, what does that mean? i.e., x is equals to negative of absolute value of x. Right? You just multiply both sides, you just isolate the x. And you take this guy inside here. Okay? So now what you have, we have is that it's a slightly different approach than what I just showed you, okay? So you're gonna replace this x by this guy, okay? So this guy replacing x. So that negative sign is going to get to place to the front. So this negative sign goes there. And absolute value of x is the same as square root of x squared. So next step, okay, so now you can use this guy to replace that guy. So when you read that, sometimes you might find these in your reading of the textbook. You say, why, how all of a sudden we have a negative sign here? They're not going to show the steps the way in such great details as I did here. They're not going to show those steps. And then you have a step, it doesn't go by you, right? It's, oh, how did you get there? Well, this is why. That's how you get the negative sign. Okay, so now finally, right, you can take this x squared. Okay, like this. Like that. You follow me? And then you take this x squared, divide into this one, and divide into that one. So in the end, okay, you have a 4 plus 3 over x. Then you could take limit. That's the calculus concept. Do you follow me? Do you want to try yourself? Try it yourself. Okay. This is the actual question I found, okay, in 8th edition of your calculus text. I'm gonna tell you the section number and the question number. So you believe me. Section 2.6, number 28. 2.6, number 28. And I believe there's there are examples that in that section in the calculus textbook, okay, they just explain the way similar to what we did, but fundamentally is using that basic relationship of about absolute value, square root of x squared, and so on and so forth. So that's the capacity you're going to use these basic algebra. And that's the capacity you're going to use these basic algebra. okay? Take your time, be patient with yourself, okay? These steps are pretty tricky. They're pretty tricky. But it has to be done that way. Otherwise, it's not going to be a mathematical truth, right? Otherwise, it's not going to be a mathematical truth. Try that. Ask questions. Okay. Be very patient with yourself, okay? You can do this. You just need a little bit of time. You need to have these things go through your pencil. And that's all. That's all. Did you get it? You see, you can do it. You can totally do it, right? So this, regarding this relationship, it's so often used. It's so often used, at least for academic reasons. At least for academic reasons. Okay. There are also situations you're going to need to use this in calculus too. Okay, so always remember that words, the narrative we have, the absolute value of a non-negative number is the same as the number. The absolute value of a negative number is its opposite. To me, if you fully understand these words, and that's the beginning of your, being able to handle all these situations, handle any absolute value situation, that's the foundation, that narrative. Okay, can you write down that narrative? I mean, truly, I fully understand it, right? In this situation, it's not just, it's the simple, just memorization is just simply not enough. The memorization is not enough, right? You have to really understand the words as they go through your mind. And I cannot replace you. I cannot do it for you. Okay, I cannot do it for you. Okay, it's through these examples we see it again and again. And in this scenario, another scenario, it deepens our understanding of those words. Okay, so let's review those words again. Okay, let's review those words again. Right, so what are the words? I want you to do it with me. The absolute value of a non-negative number is the same as the number, right? The absolute value of a negative number is its opposite. Okay. We introduced these at the beginning of the semester, right? Now we're in week 13. And somehow they pop up. They pop up again. Okay. Anyway. Your turn. Your turn. Do you guys have any questions on these steps? You guys have any questions on these steps? Can you do it? The question is, can you do it?
There was a question in chat from earlier.
I'm sorry?
There's a question in chat from earlier.
Oh, okay. Thank you for reminding me. I often forget. Okay. How did you get the square root of x squared in the denominator? How did you get the square root of x? Okay. You see, do you refer to this step, Andy? Is that a step you refer to? Oh, the next one, right? Okay, so we finally have the absolute value of x, and we know the absolute value of x is the same as the square root of x squared. So we just simply substitute the absolute value of x by the square root of x squared. You follow me? But because of we're using this branch, in the case of x less than 0, so it's a negative x is equal to the absolute value of x. So that's how we get this negative sign. So this x itself, you don't see the negative sign, but x itself is negative. Okay, x itself is negative. So if you want to make a connection between these two quantities and eventually go back here, go to this place, you have to realize that negative x, that piece I put it in the notes. Okay, if x is negative, the absolute value of x, the absolute value of a negative number is its opposite. Then we multiply both sides by negative sign, so x equals to negative absolute value of x. Do you follow? Do you follow that, Andy? Okay, so because we're using this branch, and therefore x is replaced by negative of absolute value of x, and absolute value of x is a square root of x squared. So this is the sequence of substitution. Get it? Even though this is done in calculus class textbook, okay, I'm looking at this page. The explanation they give there is in no way as detailed as we have here in class. I'm not boasting of anything. I'm really not boasting. It's just when you write a textbook, you cannot put so much details in it. You have to derive yourself. You have to derive it yourself. Okay. Okay, so in that section, in the same section that I mentioned earlier for this particular question, in that same section, there's a similar questions in the textbook. When I look at it, the explanation is there, but you have to put it to pen and to do the substitution one step at a time to make it happen, I'm not boasting what I do, but I'm asking you, you need to go into the details. So when you read any textbook, between the steps, they might have skipped a couple of steps. So when you read it, you have to fill in what's missing. They didn't miss it because they didn't like us. The author didn't like us, okay? The text, when they write it that way, it's because of all kinds of considerations. I don't know, I've never written a book. But if they fill in the steps like what we do here, your textbook will be twice as thick. You have to pay $200 more. Do you follow me? So you need to go through those steps, step by step, to fill in. Look, of course, my job is to help you to figure this out. Okay, I'm not doing anything outside my job. I'm just doing what my job asks me to do. Okay, but you need to fill in the gap. There are always gaps between the steps when even you read the textbook. Okay, I was just, whether a lot of the text did show you a lot of details. For example, a pre-algebra textbook could show you a lot of details. The pre-algebra text we see today. But our calculus textbook didn't show as much, but they point you to that direction. Okay, they point you to that direction. And it is up to us to work out the details. Okay, so we work out the details to maintain all the equal signs are validated. So did I answer your question, Andy? Or everybody's question? This is very tricky. Okay? But it's not impossible. It's not hard. It's just how you work out those details, right? But anyway, without further ado, and I think I give you a pretty good preview about the calculus class, right? That's what you're gonna see. That's what you're gonna see. You're gonna be dealing with, okay? All right, and why it is so important that we focus on these basics, right? We focus on these basics, how to use them, okay? Memorization is not going to serve you terribly well. Okay, so let's do a few more. Your turn. Okay, this one is also a question from your calculus text. Okay, number 8. Number 8. We have a t squared plus 9 in the square root minus 3, and the denominator is t squared. Okay, so rationalize the numerator. How about you? Would you like to try that? I think you can do it. Maybe you want to do 11 as well. Number 8, number 11, they're all from your calculus textbook. Okay, they are from your calculus textbook. Nothing really has changed. From one edition to another edition, the author might have changed the numbers here and there, but the essentials of those questions has not changed. Okay, some of the numbers have changed, but not the essential techniques. Not the essential techniques. And if we have time, maybe we'll get to number 14. Okay, I'm just selecting these questions. And if you guys, as you work on these questions and you have questions, feel free to ask. Okay, I'm just selecting some questions that I think might be a good one for you. But you are going to go through every question. You're going to go through every question. That's what I hope. Okay, you should do that because most of these questions I've put in here, they're really just exactly the same calculus questions for finding limit or finding derivative or finding whatever. Okay, this is truly a preview of your calculus class. Okay, so work on these 3 questions. They have some typical, they're rather representative, okay, of the techniques that you might need to acquire. And you need to also to show your work. Okay, the other thing is that once you know how to do it, right, you have to show your work nicely. You have to show your work beautifully. Because you want to get points from your professors, don't you? Yeah. Okay, so the way I show you the work, right? My goal is the work I show you is flawless. Because that's, I should. Do I make mistakes? Of course I do. Not intentionally. Some of the steps may be skipped, but it cannot be overlooked. Okay, you need to show your work flawlessly in order to get those full credits. Okay, so that takes practice as well. Okay. And if you would like to have more exercise, there's a 35B. There's a 35B. Okay. If any one of you like to show your work, and I'll be happy to view it. Yay, nice. Thank you, Bailey. Okay, guys, let's look at Bailey's submission here. Thank you for your submission, Bailey. Okay, so we have, that's his work. Can you guys see? Another submission, Andy. Thank you, Andy. I'll get to yours after Bailey's. Okay. When you write your work, okay, this is very good. This is very good. So equal sign. And over here, I will make it very clear. Okay, I will make it very clear, plus, okay? There's something called an eraser, okay? When it's not, I know you would do better, but you just have a habit of doing that. Just have a habit of doing that, okay? And so when I check your work, I want to show you how exactly your professor will grade your work. I will check equal if the equal sign is justified. Okay. Of course, if you say, oh, I'm not going to give you equal sign, you're missing equal sign, and I will also take points off. I will mainly check the equal sign because this is a statement. This is not an if statement. You don't have another side. Okay, this is a statement, not if statement, expression, if you say, right? So, and this is a grade. And so I'll be checking these steps And what I see is missing already is the parentheses. Right? Do you see that? Even though this is a minor detail, it's a very important detail. Okay, so that's how I grade your work. That's how I grade your work. Okay, it's a very good job, Bailey. You did a very good job. But still, there are all these details I want you to attend to, right? And he showed all these work very nicely, and he get the right answer. Perfect. Okay, just missing some parentheses, right? That's easy to correct. You only get better. You only get better, right? All right, so very good job, Bailey. Thank you for your submission. So let's look at Andy's. Okay, did you guys write it down? Okay, excellent. Okay. Andy's work. Very nice. Okay, very nice. Okay, so we have, I'm going to check your equal sign. The conjugate, okay? And this piece here, this bar is a little too long, okay? But it doesn't bother anything yet. It could bother, okay? So just don't make this too long, okay? So just cross it out, okay? Cross it out, okay? Very good work here. Equal sign is justified. Very good. Okay here. This is not long enough. Okay. But overall, it's a very good piece of work. If you just make those corrections as I did here, this is very common. Okay. So when you write your fraction bar, you want to make sure it starts from the place you mean to, it ends at the place it's supposed to. Okay, because if you don't have that, it could be judged very ambiguously, and it could be you could be losing a point or two. But you don't want that to happen, do you? You don't want that to happen. Okay, you want your work spotless. You want your work spotless, flawless, so no one can take a point off your work. Isn't that what you wanted? Isn't that what you wanted? That would be something I wanted if I were a student. I'm not a student today, but the work I show you, that's the goal I try to reach. I will show you work that can withstand the test of time. Especially I'm on the recording, right? Especially I'm on the recording. And for you too, you want to present a piece of work to your professor, okay? And that piece of work you do, right? 20 years down the road, you show that to your grandson, granddaughter. It's still perfect work. How would you like that? Right? Mathematical work has to withstand the test of time. And it has to. It has, the existing acknowledged mathematical work has been has withstand the test of time over the centuries. If you think about that work you do in that capacity, and you are able to do it, and you should be very proud of yourself. The work you do is going to withstand the test of time. Okay. And I don't see there are a lot of things in the world that will really withstand the test of time. Okay. Even the flowers has, it bloom and it will wither. But your work, you want it to be that amazing. You want it to be that amazing, okay? But anyway, so we've done 2 questions. Very good job, gentlemen. And I appreciate your contribution. And it's particularly beneficial for my lecture, okay? Because we get to interact through your questions. And you can see there's no penalty for you, right? It will the only intention is to make us all better. All right. So anybody else who would like to turn in your work? So we did number 8, we did number 11. How about number 14? Okay, so I'm going to do number 14 then, okay? Because we're running out of time. On number 14, it looks pretty messy, isn't it? Well, if you notice that there's a t as a denominator, you might like to do something like this. You might like to factor this out. Excuse me. Wouldn't you? Would you like to do that? I would. If I recognize there's a common factor, I will factor it. So that will make my life much simpler. Okay, and 1. I'm going to use the common denominator here. I mean, this is not the only way to do it, okay? When you do algebra, you want to always have another way to do it. Almost always. Almost always. So I get the common denominator. And then I will reduce I will do the subtraction. So now I get a 1 minus the square root of that, right? So this term is gone. It turned into something like that. Okay, and rationalizing. When you're rationalizing, you only have to worry about this piece. Okay, so that's going to be the conjugate 1 plus t multiplied by 1. Okay, and then you keep the denominator together. Okay, and the numerator, so this is gone, right? And this is a 1 squared minus that guy's squared, right? So this is 1. How about the numerator? I'm going to bring the numerator together, t, right? And over here, I'll have the parentheses over here. So I'm going to move all of these together, compact, and in factored form. You will find that throughout your calculus classes, in a lot of situations, I'm not saying in every situation, in a lot of situations, especially calculus 1, you want to keep everything in factored form. You want to keep everything in factored form. So that's why I'm not going to multiply these out. I'm not going to take this multiply by 1 and take this and multiply this guy. Just keep it the factored form. And the top, what do we have on the top? Well, 1 squared is just 1, right? And this guy is going to be 1 plus t, right? And opened up the parentheses, minus t, right? And 1 minus 1, and so you have a negative t on top. And this t and that t will reduce. So this is going to be negative 1, and this is going to be the final answer. You're done. you're done for this class. Not for calculus class. For calculus class, it depends on the situation. You might have to take a limit or do whatever. Most likely you're going to be taking a limit. Okay. All right. So we still have some time left. This time you guys are going to choose freely. Okay, you guys are going to choose freely. We might be able to do one or two more questions. Okay. So I want you guys through this process to master this technique of rationalizing the numerator, which is a technique you're much in need of. Okay. They probably usually constitute like 10 to 20 points for your calculus class grades. Okay. So now you freely choose questions, maybe one or two. Maybe you choose one for me, I'll do it for you. And you do the practice after class. You want to do that? Which question you wish me to do for you that you think you might not be? Well, I think you can do all of them. You can do all of them. I have no doubt. You just have to put in action. Okay, you take those actions. No, you good? Are we good? Okay, notice that if you want to have more exercise, there's a basic 35B, okay, basic 35B. And next time, which is tomorrow, I want to get to basic 36. Basic 36 is it's about factoring and the general theories about factoring. Okay, even long division. Did you guys hear about long division before? Yeah. So basic 36, even though I didn't put a lot of questions there, You can see the title. I have listed a sequence of theorems. I've listed a series of theorems. Okay, this probably reminds you of the long divisions, right? Do you guys look at the notes? This is the notes, right? Do you see it? Remainder theorem, factor theorem, rational zero theorem, and fundamental theorem of algebra, complete factorization theorem, and zero theorem, right? And conjugate zero theorem and linear or quadratic factors. Did you hear the word quadratic, right? We have a section of everything quadratic? Okay, quadratic has a lot of applications, But anyway, so tomorrow we're going to focus on discussing these, the theory. What does the theory tell us? Okay, because theory is very powerful tool. Okay, in your calculus classes, you will learn a lot of theories. Okay, you learn a lot of theories. And theory is a very powerful tool. So we have to make sure we understand that theory. A lot of theories will guarantee certain results, even though it may be very difficult to get those results. Okay, but theories are very powerful, and especially for people who are not majoring mathematics, theory is just as important. For people who study mathematics as a major, theory is important, of course. For people who do not study mathematics as a major, theory is also very important because you're going to apply the theory to your specific field. Okay, so that's make it even more important, right? So you're going to use those theories in your engineering, in your software engineering, electrical engineering, mechanical engineering, and so on and so forth. So theory is very important. So tomorrow we're going to study this section. I will just give you an overview and explain to you what it means. And we're also going to review about factoring. Okay, review a little bit about factoring. Okay. Hopefully this will not take too long. And you guys can get started doing these factorings. Okay, like basic 37, basic 38, basic 39A, and so on and so forth. Okay, and you can see there's lots of variations you're going to see in calculus classes. Okay, but they involve a lot of factoring. I think looking ahead, that's what we're going to do tomorrow. You can view this as a review of factoring in general. Factoring in general. Okay, in elementary algebra, we factored a bunch of stuff. Intermediate algebra, we factored a bunch of stuff, right? We factored quadratic and so on and so forth. And how about factoring in general, right? What does theory guarantee us what we can get? And various other situations. Okay, and these factoring technique will be permeated throughout your academic, especially math courses. Okay, in your calculus class in chapter 3, chapter 4, you realize, oh gosh, I have to do factoring, right? And just as we were doing 35A, I remind you, leave it in the factored form. Leave it in the factored form. Okay, leave it in the factored form, right? Leave it in the factored form. Leave it in the factored form. Look at these, right? Leave it in the factored form, right? Then you say, why? Right? Would you be asked that question? Why do I leave it in the factored form? You will have those questions answered over time. Okay. And one of the reasons we already know, that's because of principle number 5 and principle number 6. It's that simple. Okay. The 6 principles we learned this semester, well, you have been learning that all along. But the 6 principles we emphasized over and over again. And those are the primary drivers and reasons that we want to keep those things in factor form. Of course, keep those things in factor form has other benefit as well, which you will see not only in this semester, you're going to see more in your calculus classes. Okay, so without further ado, and I think I'll be looking forward to seeing you tomorrow, and wish you have a great day. Thank you. Very good job. Very good job participating. And I'll see you guys in the morning tomorrow. Let's see what's on the chat. I'm sorry, I forgot. Okay. If you have any questions, feel free to come to my office and I'll be there right away.